Hello, thank you for watching this video. So in this video, I'll be doing question 1 of May-June 2024 question paper mathematics paper 2. The topics is the statistics, or what others would like to call data handling. So I'll read question 1 statement and then try to answer the questions that follow. So let's go. They're saying the number of pages of 10 A4 books and their corresponding weights in grams are given in the table below. The data is represented in the scatter plot as well. Let me read this thing again. They're saying the number of pages in 10 A4 books and their corresponding weights in grams are given in the table below. The data is also represented in the scatter plot. Fine. So what is happening? So you can see this table here. This table here contains 10 A4 books. So this is book number 1, book number 2, book number 3, book number 4, book number 5, book number 6, book number 7, book number 8, book number 9, book number 10, right? So there's 10 of those books. What are A4 books? I'm sure you're familiar with them. So A4 books are the books that you normally use to write on, maybe at school most of the time. It's a pity that I don't have, or actually I do have one. I'm sure you might be familiar with these books here. This is a 2-quire, right? It has 192 pages. So its size is A4. These are the ones that we normally write on our classwork. Actually, even our exam writing sheets are also in A4 size. So I'm sure you've seen all books of this size. So these are A4 books. So they have given us 10 of them. You can see here is the 10 and the weight of each, right? Here is book number 1. Book number 1 contains 85 pages because on the top row, these are pages. On the bottom row, these are the respective weights, or those are the corresponding weights. No problem. So the first book have 85 pages. As you can see, here is 85. Number of pages, 85. The second, its weight is 165 grams, right? Book number 2 contains 150 pages. You can see there. Its weight is 325 grams. Book number 3 contains 100 pages. Its weight is 200 grams. Book number 4 contains 120 pages. Its weight is 250 grams. This continues up until the 10th book. And the 10th book, here is it. It has 160 pages and the weight of 340 grams. So you are given the number of pages of each book. All these books are of the same size, or actually not the same size in terms of the size of the pages, which is the dimensions of the pages are the same. They are all A4. But now the thicknesses of these books are all different, because they all depend on what? That all depends on the number of pages, the thickness. Because the more pages you have, the thicker the book. The fewer pages you have, the thinner the book. Right? No problem. So this is what we're given here, number of pages and the weight of each book. So if I'm talk about book number 10, here's book number 10. It has 160 pages and 240 grams. So you are given all this information for all these 10 books that are all A4 size. No problem. So this information here, they have also plotted it here. You can see down here, you have the number of pages. They have plotted the number of pages on your X, and on the Y-axis, this is your weight in grams. Right? On the X-axis, you are given the number of, they plotted the number of pages on the X-axis and grams on the Y-axis. So you can see the first book was on 85, right? The first book was on 85. Oh, the first book had 85 pages and 165 grams of weight. So you can see here is 80. Here, this is 80. So okay, let me do this actually. So you can see here, this is the counting interval is 20. So you start at 0 on the number of pages at least. So 0, 20, 40, 60, 80, 100, 120, 140, 160, 180. Right? But then now, there are these small lines here. You don't know the value of each of these small lines here. But you know from 0 to 20, it's 1, 2, 3, 4. It's 4 lines to go to 20. Right? Let me do this again. So from 0 here to 20, you is 1, 2, 3, 4, which is 4 lines. So if you want to know what is the value of each line, what you need to do, you say the first value, the first numerical value here, which is 20, or the first numerical value from 0, divide by the number of lines. Then you will know the value of each line. So in this case, what do we have? In this case, the first value that you encounter from 0 is 20. Here is it, right? And how many lines? Is 1, 2, 3, 4. So if you want to know the value of each line, the value of each line will be the number, or will be the first number from 0, which is 20. Here is 0, the first number from 0, or first written number from 0, or recorded. It's, yes, divided by the number of lines. So it's going to be 20, right? It's going to be 20 divided by the number of lines. How many lines? It's 1, 2, 3, 4. So divided by 4. What is the answer? The answer that you get is 5. So what this means is that each line that you see here on the horizontal axis, which is on the number of pages down here, it represents what? It represents 5 units, right? So each line here, each line is 5 units. Because so you can say this is 5, 10, 15, 20, 25, 30, 35, 40, which makes sense. 45, 50, 55, 60, which makes sense. So each of the lines here is what? Is 20. It's 20 units. Or maybe 20 pages, if in that case, because these are number of pages. You can do that on the vertical as well. So on the vertical, the first number that you see is what? Is 50. How many lines did it take you from 0 to 50? It's 1, 2, 3, 4, 5. It's 5 lines from 0 to 50. So now, let me count again. It's from here is 0. From 0 to 50 is 1, 2, 3, 4, 5. So it's 5 lines to move from 0 to 50. So if you want to know the value of each line, you're going to say 50 divided by the number of lines. The number of lines is 5. So each line on the vertical scale, on the scale here, each line is what? Is 10 grams. It's 10 units, which is 10 grams in this case, because your units are grams. So which means if I'm counting each line here, I know I'm counting 5 units. If I'm counting each line on the vertical, I know it's 10 units. Fine. So what do we do now? So you can see here, let's look at this relationship here. Let's look at this relationship. You can see that as you increase the number of pages on each book, the weight is also increasing, because you can see that look, you had 85 here, right? Here's 85, here is it. If you look down here, it corresponds to, so this is 80, this x is 85, sorry, x is 85 here. So here's the point that corresponds to 85. So if you read this down on this side, you will read it somewhere here in the middle here. So you know that each line represents 10 units. So if this is 50, this is 60, so this should be something like 65 or something, because it's in the middle, because point number 85 is plotted exactly in the middle of 2 lines. And you know that the difference between these 2 lines is 10 units, because each line is worth 10 units. So if this is plotted in the middle of the line, it means it is about a half, more or less, or anything in between. So in this case, it's safe to say it's about 165. You can see it's also 165 there as well, right? No problem. So you can see that this function of yours is, oh, actually not the function. If you were to put a trend line here, it would sit over this function like this. You can see that it's increasing, right? You can see it's increasing. As you increase the number of pages, this one also increases as well. It's going up. So you can see that there's a positive relationship between the number of pages and the weight. What does this mean? It means the more number of pages that you add, the more weight you will have for each book, which is the increase in number of pages will cause an increase on the weight of each book. This is what this thing means. That's the relationship that you get from this. So which means there's a positive relationship. Actually, I can go further and say there's a positive, strong relationship or strong correlation between the number of pages and the weight. It does make sense, because if a book is a college exercise book is about 72 pages. A college exercise book does not weigh more than a 2 quire, which is made up of 192 pages. So the more pages you have, the more material you have, the more matter you have making up that book, which means the more heavy it will be, the more weight it will carry. So I think that is clear. So I'm done with this. Then I'll go to the next, to the questions. But you should be able to analyze the scatter plot. You can see that I have a strong positive relationship here. I have a strong positive correlation here. At least you should be able to see it from the diagram itself. So I'll move on to 1.1. Okay, so now let's do 1.1. 1.1 read as follow. They are saying determine the equation of the least squares regression line. Right? They are saying determine the equation of the least squares regression line. So what is what is the equation for the least squares regression line? So it is, I would say, in simple terms for you at least, I would say it is an equation that is representative, or maybe that is a line of best fit to this plot that we have here. So it is a line of best fit, which when you plot it, it will tell you the trend of these values that you can see here, of this positive, strong positive correlation or relationship that you can see here. So they want us to find an equation that represents the line of best fit for this equation here, for this scatter plot that you can see here. That's what they want us to find. So you might know by now, if you want to calculate your equation of the equation, or your equation of the least, your equation for the least squares regression line, this is 1.1, right? Is in the form y is equal to a plus bx. It's in this form. It's a line, right? As you can see. So they want you to find this line here. So in order to find this line, you must find your a and find the value of b. And you know, for grade 12 at least, we use calculator to find a and b. So how do we do that? So let's use our calculator. The first thing that you need to do, if you have a calculator similar to mine, you need to enter all that information on your calculator. And then your calculator will be able to give you the value of A and find you the value of B. And in that case, you will know, you will have your equation for the least squares regression line, because you have the value of A and you have the value of B. So how do we do that? So to do this, you need to put your calculator on statistics mode, right? How do you do that? You press mode here if you have a calculator like mine. Here is it. So you want to put your calculator in statistics mode because you're busy with some sort of statistics here. Then option 1, option 2. Statistics is option 2. So you select option 2. Then after selecting option 2, you can see that you are given many options here. Option 1, which is variance, your means, your modes, your standard deviations, and all other stuff, right? Option 2, you can see that option 2, it looks like this because you have A plus bx. So option 2, which have A plus bx, which resembles this equation of the least squares regression, right? So you select option 2, which resembles the equation of the least squares regression line. So select option 2. So you can see here you are given two columns, x column and the y column. So what you enter on this x column is all the x values that you see there, which is you enter your number of pages, the first row. So on the first column, x column here, you will enter the x row, which is the first row on your table there. So that's what we're going to do. So let's do that. What do we do? The first x value is 85, so you enter 85. To save it, you press equal to. The second value there is 150, press 150, you save it with equal to. The third one is 100, save. 120, you save. 90, you save. 140, you save. 135, you save. 105, you save. 115, you save. 160, you save. So you can see that you have 10 entries, which should be correct because look, if you look at that data of yours, you know you have 10 books, so you should have 10 books that, you should have 10 books that should be corresponding to this. So you double check. It's 160, 115, 105, 135, 140, 90, 120, 100, 150, then 85. So all the number of pages are entered correctly. So now we're going to the Y column. On the Y column, we put the Y's there, which is the weight in grams. So the X represent the number of pages and Y represent the weight in grams. So let's save that. So the first book, which was 85 pages, contained 165 grams, right? The second book, which was 150 grams, which was 150 pages, weighed 325 grams. Your 100 pages weighed 200 grams. Your 120 pages weighed 250 grams. Your 90 pages weighed 180 grams, right? And your 140 pages and 285 grams. And your 135 weighed what? 250. Your 105 weighed 107. You can see it over there. And your 115 pages weighed 230. And finally, your 160 pages weighed what? 340 grams. So you have entered all this information. So what do you do from here? So say cancel. Done. Then now you want the equation for the least squares regression line, right? So you need to find the value of A and find the value of B. How do you do this? So you say shift, right? And then go to statistics, which is option 1. Fine. So you have so many options here, but you want a regression. Regression is option number 5. So press option number 5. That's where your regression is. So you can see here, you have your A, which is this. You have your B, which is that. You have your R, which is your correlation coefficient. Tells you the relationship or indicates the strength of the relationship between your number of pages and your weight in this case. So, but what we're interested in, the value of A. So let's find the value of A. The value of A is equal to minus 43.72. So we'll write it down that our A here is equal to minus 43.72. Then we also need B as well. How do we find B? We find B the same way. You say shift statistics, then you go to regression again, option number 5. Then there is your B, option number 2. Say B, which is equal to. So you get that your B is equal to 2.36. So you have your A, you have your B. So what you need to find, what you do now, just substitute your A there and substitute your B there. Then you will have your equation for the least squares regression line. So in that case, what do we have? We have that our equation for the least squares regression Y is equal to A, which is equal to minus 43.72 plus 2.36x. Right? Or maybe let me write it nicely and say Y is equal to minus 43.72 plus 2.36, maybe x like this. So this is your equation for the least squares regression line, right? So this equation, you can use it to interpolate or extrapolate, which means in that case, if you are given maybe some number of pages, you can use this line to estimate what will be the weight, or if you're given the weight, you can kind of estimate the number of pages, which is finding the x value in that case, right? No problem. So let's move. Now we're going to 1.2. What are they saying at 1.2? At 1.2, they are saying now, draw the least squares regression line on the scatter plot in the answer book. So they want us to draw this line, this least squares regression line, on our scatter plot on that answer book, right? problem. So what do we do? So to do this, you need to, okay, here's what I advise you to do, which is what I do. You take the biggest, the thinnest book here, which contains the least number of pages, which is 85, right? So 85 is the thinnest. It contains the least number of pages. And the thickest, which is the one that contains the most number of pages, which is 160, right? What I will say do, take this number of pages and take that number of pages. And then use your least squares regression line to estimate the weight according to that, to your line of best fit, which is your least squares regression line. Use that equation to estimate the position of the line of best fit on your plot. Find this lowest endpoint and that largest endpoint, right? Once you do that, you can just join the 2 points. So I'm just going to do that. So you take the smallest point, which is 85. So at x, when x is equal to 85, you are given that the number of pages will be 165, right? Fine. But now you're going to use this 85 to estimate the value of this, to see where your regression line will pass. The position which will your least squares regression line will be passing through. So in this case, what you'll do is, okay, I'll find y at 85, right, to be equal to minus 43.72 plus 2.36 times x. What is x? X is the number of pages, which is 85. So find your y at 85. What is it? Let's punch that and see the answer. So we say minus 43.72 plus 2.36 times 85. Your answer is 156.88. So you get that if your book, actually, you are told that your 185 book will contain will have a weight of 165 grams, right? But now the regression line is telling you where the line of best fit is crossing, which is where the line of best fit, which is a representative line of this data, is passing. It's passing at this position at 156.88. So if your book have 85 pages, on the regression line, it will lie at 156.88 grams, right? Also take the end point, which is 165, the thickest one. So your x at 160. So you find your y at 160 to be equal to minus 43.72 plus 2.36 into 160 pages. So you find that the weight of this book, of this 160 page book, will lie on the regression line on the weight that we'll find here. So let's say 160. So it will lie at 333.8, more or less, right? So this is where it will lie. So what you need to do now, you have your x, or actually this is what, so you have the x coordinate to be 85 and the y coordinate to be 156. So the x coordinate is 160 and the y coordinate is 333.88. So what you need to do now, you need to plot these extreme points, or these end points, both of them, and then just join them by the line. That's all you need to do. So that's what we're going to do. So at this point, let's go and find them. So we say we have 85, it goes with what? With 156. So where is 85? So we said each line is 5 units. So this is 8, 85 is here. Here is it. It goes with 156 or 158 unit, or 157, 156 or 157. 156.88 or maybe just 157. So here is 80, 85. Here is 85 here. Right? And then now let's go and find 156. So this is 150 right here. We said each line is 10 units. So this is 160. So this regression line should lie on this line somewhere here. Should be somewhere here. Here's it. So should be this point somewhere here. Because this is 150, 160. So 156 is in between. It's here. No problem. We point the other end point, which is 160 and 330. Here is 160 down here. Let's go and find 333. So here is 300. We said each line is 10 units up here. So the first line is 310, 320, 330. 330 is here. So 333 maybe is just above this line, somewhere there. So if you were to plot both of these positions, they'll be plotting somewhere. 30. These 2 points will be plotting somewhere here. So I said, let me just double check something. So I said this is the 300, 310, 320, 330, just above here. So it should be here. So your regression line now, if you want to plot it, just join those two endpoints. This point here and that point over there. Just join them like this. That is your least squares regression line plotted on your scatter plot. I don't have the answer book, so I think it would look like something similar to this. So I'm done with 1.1, I'm done with 1.2, I'm going to 1.3 now. What are they saying at 1.3? They are saying now, predict the weight of an A4 book that contains 110 pages, right? So they want us to predict the weight of an A4 book, right? That has 110 pages. So you can do that using your least squares regression line, because if you look at it, here is your least squares regression line. You are given that the number of pages is 110. So they want you to find the weight. So you know that your y is the weight and x is the number of pages. Y is the weight in grams and x is the number of pages. So you are given the number of pages, which is you are given x. So you can substitute your x, which is 110 here, and then you will get your weight, right? You can substitute straight away on this equation. Put 110 there and then get the weight straight away. Or what you can do, you can use our graph to try to estimate, using our graph, the weight of a book that contains 110 pages. So I'm going to do both. So let's try to do that and see how do these two compare. So I'm going to remove this. I'm done with it. So I'm going to go to another paper. And on this new paper, I'm doing 1.3, right? This is 1.3 what I'm doing here. And this 1.3 we're given, we calculate that the least squares regression line is y is equal to minus 43.72 plus 2.36x. So this is our equation for the least squares regression line. It's what one of the ways we're going to use to estimate the weight of a book. So by graph, I'm going to use graph first, or I'm going to use scatter plot that we're given. So what asked here, right? What they have asked us to do, they have asked us to predict the weight of a book that contains 110 pages. Number of pages is x, you can see there, which means you're given that your x is equal to 110 pages. Your x is 110 because you are given the number of pages, so they want you to find the weight, right? Because you can see even here on the x-axis you have number of pages. Even there, number of pages is x. So if you're given the number of pages, you're given x. So they want you to find the number of pages, which is y. So that is what we're going to do. We're going to find y. So let's go and find that y. So what we're going to do, let's use the graph first. Since we're looking for 110, right? X is 110. Let's go and locate this 110 on the graph. 110 on the graph. This is 100, right? And we said each line on the horizontal is 5 units. Because we said each line on the horizontal scale is 5 units. So if this is 100, this is 105, this is 110. So 110 is here. This is your 110. So what you do, you draw a vertical line to your line of best fit or your regression line. So you've drawn this line here. You've joined your 110 line to the the regression line. And then where you are here, where you've hit here, you join on the y-axis so that you can read the number of pages there. Right? Doesn't look very straight. Okay. So it reads here. So we know this is 200, right? This is 210, this black line. So it's just above this black line. So if I were to estimate, it's just above this black line. If I were to estimate, thinking that this is 10, I would say this is more like 200 and maybe 213 or 214. Because you can see between the two black lines, the distance the difference in weight is 10 grams. So here is 200. So we know that our point that we're trying to estimate is above the black line, which is more than 10 units from 200. So this is 210 here. So it's just above 210. So it should be something like 213 or 214. So using the graph, which is what we're doing here, what I can say that y, which is the number of pages, it should be about 214 grams. That should be the weight. So if you use the graph the way that I did here, by finding the number of pages, then join them to the line of best fit or the regression line, then read them there, you can see that if you have 110 pages of a book, it will have a weight of about 214 grams. But then now you can also estimate this using the regression line. If you're using the regression line, you'll say, okay, y is equal to negative 43.72 plus 2.36 times x. What is x? X is the number of pages, which is 110. So you get that your y is equal to, this is the number of pages that you will get here. So, because y is the number of pages, as you have seen in the diagram, that your y represents the number of pages. So let's punch it and see what we get. It's okay, minus 43.72 plus 2.36 times 110. So get something like 215.88 grams. So this will be the weight. So if a book contains 110 pages, it will have a weight of 215.88. You can see that the difference is about between the graph one and the, and from the regression line is about 2 grams more or less. Just about 2 grams. So this is close enough. I'm sure they would accept this, especially if they see that you try to use a graph like that, because you use the graph there, but here you're using the regression line. So I'll say this one is a closer one than that one. Okay, let's move. So what are they saying now? We're doing 1.4 now. They are saying now at 1.4, calculate the percentage of weight increase of a book with 110 pages and a book with 130 pages. Okay, so this is 1.4 that we're doing. They want us to find the weight increase between a book with 110 pages and a book with 130 pages. So in a simple way of thinking about it, just think of a book, right? So you have a book here. This book is made and it contains 110 pages, right? And now let's suppose that we add 20 more pages to this book. We add plus 20 more pages. If we add 20 more pages to this book, it will be same book with what? With 130 pages. So this is what just think of this equation as this one. You had a book that has 110 pages and you added 20 more pages, it became 130. So what they want you to find, they want you to find the average increase in the weight of this book to become 130 pages. What is the percentage increase in the weight of this book? Not in the number of pages. In the weight of this book to become that 130 pages. But this is not what this statement is saying. This statement is saying they wanted to calculate the weight increase between two books of 110 pages and a book of 130 pages. I'm just trying to make a scenario that will make sense to you. You had a book that was 110 pages, and then on that book that was 110 pages, they added 20 more pages, it became 130. So these two will have different weights now. You know the book with 110 pages up here, it had a weight of what? The weight of book of 110 pages, it was 215.88 grams. This was the weight of a 110 page book. It was 215.88. So what you need to find what is the weight of this new book, or not on the new book, but of the book with added pages. Then now, what you need to find now, once you know the weight of this, you can find the percentage increase about what is the weight increase between these two books, right? So what you need to find the weight of the 130 page book. Once you find it, you find the difference between the weights of these two books and find the percentage increase of the 110 page book. So what you need to find the weight of this 130 page book. Let's go and find the weight of this 130 page book. I'm going to use another paper because I'm done with this one. So y is equal to minus 43.72 plus 2.36 x, right? So you're told that the number of pages of the new book is 130 pages. You already have the number of pages for 110 page book because we calculated up here and they came up to be 215.88. So let's go and find the weight of the new book, the one with the added 20 pages. So your y is equal to minus 43.72 plus 2.36 times x. X is the number of pages, which is 130. Then what else that you'll get here will be your weight, because y is the weight. So let's go and find that weight. So we're going to put 130 here. You get that your weight is equal to, the weight of the 130 page book is 263.08 grams. So here is what is happening. The book that contains now, the new book with 130 pages, have this weight. So here's what happened. You move from book 1 to book 2, right? Book 1 had 110 pages. And you added 20 more pages, right? To get to 130 pages of book 2, or new book if you want it. The weight of the book 1, we calculated at 1.3, and it was 215.88 grams. And you added something, which is that's something that you added here, is what we're interested in. And now you know that the new book, the weight of the new book is what? The weight of the new book is 263 grams. 263, this should be 6.08 grams. So now, what is it that you want? What you want the percentage increase about what is the percentage of weight increase from this amount, right? So if you want your percentage increase of your book, whatever, it should be the difference between the weights, which is what you added over this, times 100. right? Because if you wanted the percentage of page increase, it was going to be 20 over 110 times 100, right? But now, want the weight increase, what the percentage weight increase. So it should be the difference between these two, which is whatever it is that you added here. Because what you added here is the difference between the two things. Because the difference between 110 and 130 is 20. Is that 20 that you added? So if you wanted the percentage weight increase, it's this amount here, which is the amount that you added on this to get that. So you need to find the difference between these two. This minus this, which is 263.08 minus 215.88. This is the what you added, which is the weight increase, divided by your total, which is the total of the book you are using as a reference. The book you want, the book that you want to use as a reference, the one you are investigating is the increase from it, right? It's because you're calculating the percentage increase from a 110 page book. So you're going to use the weight of the 110 page book, which is 215.88. Then you multiply by 100 this thing. So this will give you a percentage. So your percentage increase, looks like it's raining, is equal to the answer to this. So just punch that, because this is the percentage increase of your 110 page book. So I'm going to clean all of this. I don't think I'll need it anymore. So you say 263.08 minus 215.88 all over 215.88 times 100. So what you get is that the percentage increase, the percentage weight increase is 21.86%. What does this mean? It means that from this 110 page book to that 130 page book, you added 20 pages, right? No problem. The weight, this weight from this to that, it increased by 21.86%, which means you added 21.86% of this on this amount to get to that. That's what you did. So it's more like you added 21 or 22% of this weight on it to get to that amount. So we're done here. And I hope this question does make sense to you, as it does to me. Thank you for watching. If you're still watching, cheers.